This is Mrs. O'Neill for AP Chemistry, Chapter 11, Section 2, Part 2, Intermolecular Forces, an Introduction, or an Introduction on IMFs. So your objective is going to be distinguished between intra versus intermolecular forces. And there are four intermolecular forces: dispersion, dipole-dipole, hydrogen, and ion dipole. So again, this is just an introduction to get you to understand what these forces are. And again, the more times you hear this information, the better it sticks, because this is a little bit harder of a concept to understand. So pause the video, fill in the blanks, again, read as you write, and then play to hear my words. So what is the difference between an intra versus an intermolecular force? Well, intra is the actual human bond that we say is there between the atoms that make up that unit, that make up that molecule, right? So these are inside the molecule. Intermolecular, however, is going to be a molecule and how that force of attraction is between another molecule of the same thing. Remember that every time we talk about things or a measurement of things, it's always about 1 mole of that substance. Well, 1 mole is 6.02 times 10 to the 23rd. So that's a lot of atoms or a lot of molecules. So how do those atoms or molecules actually stay together or hold on to each other in that substance? So that's what inter really corresponds to. So I'm going to show you 2 pictures, and then I'm going to show you the 2 pictures on one slide. So you're going to have to draw in your notes what intra would be versus what inter would be. So again, intra is the actual bond between the 2 atoms that make up what's called this diatomic molecule. Okay, and we call this an actual covalent bond, right? Because it's 2 nonmetals together and they're bonded together with this bond in between. Usually it's like a line or 2 dots, right, to represent the 2 electrons that they're sharing. But notice these dashed lines between this chlorine diatomic molecule and this chlorine compound, right? So what's that dashed line for? Well, this is what's called the IMF, or the intermolecular force. It's the attraction or the force of attraction that's actually holding these 2 chlorine molecules together. So again, this is another way of looking at it. And again, I always try to give you some mnemonics on how to remember this. So again, intra is the bond that's holding the H and the Cl together as a molecule versus the H and the Cl. So this molecule and this molecule, there's an attraction between these 2 molecules, and that's going to be intermolecular. You can also think of things like international. So like when you go to Europe, right, you call Europe all of those different countries together, but each individual country is its own country. So that would be intra, right? Italians are Italians and Spanish people are Spanish people, right? So those are the bonds that are held within that certain country. However, between Italy and Spain, or Italy and Switzerland or whatever, that's international, right? It's going to be the bond or the barrier, the boundary between the 2 countries. So at this point, make sure that you draw, whether you want to go back and rewind and actually see the notations, or you can just pause the video here and make sure you're understanding the difference between intra and inter. So pause again and read. I'm going to have you reading a lot, especially in this section, because again, it's just more information, and over again to make sure you're understanding the different types of intermolecular forces. So again, some visuals to get you to understand what that bonding means. So again, these are intramolecular bondings. You already understand ionic, covalent, and molecular. And this is just some good information about the energy and some examples and what the attraction is. And now there's a whole bunch of what's called intermolecular force. So if you notice, these are also dashed lines. Well, they're dashed lines because it is, in this case, an ion and a dipole molecule, and it's the attraction between the 2. And again, it gives you some bond energies, and it gives you some examples. So pause for a moment and make sure that you're understanding what this is. And you should have somewhat of a background knowledge because of all those intro videos that you watched. So again, the difference between intra versus inter. So pause the video and please read this. So in general, the stronger the intermolecular forces, the higher those melting points are going to be of the solids and the higher the boiling points of the liquids. And hopefully this makes sense. Anything that's stronger is going to take more energy to pull them apart. And this is what I mean by we're not really going to be breaking bonds here, because again, a bond to me is two atoms held together. They're either sharing or transferring those electrons to make that ionic or covalent bond. This is the force of attraction that is causing those, let's say, H2O molecules to spread farther apart, going from the ice to the liquid. So your melting point of that H2O solid to H2O liquid, it's going to be stronger when we have stronger IMFs. So that should make sense, right? If you have a stronger force of attraction, it's going to take more energy to separate those molecules from each other. So again, pause the video and read this information. So again, if we look at these molecules, and this is why we did organic in the very beginning of the course, because again, we have 4 organic molecules. We have methane, CH4, ethane, propane, and butane, and it's N-butane because it's just the chain. It's not one of those isotopes. So we are increasing the molar mass of our substances, and look at what's happening to the boiling point. So again, you have stronger IMFs because you have more bonds to break. So same thing with surface area. If we look at these two guys, so we have what's called dimethyl propane and just regular pentane, right? So again, these are isomers of each other. So they have the same chemical formula and they have the same molar mass. But now let's look at its boiling point. So we have 9.5 versus 36. Why is this have a higher boiling point? Because there's a lot more surface area. So again, it's going to be stronger. More surface area tells us that it's going to be stronger. So it's going to be harder to break all of those bonds in a chain versus the bonds that are kind of like in a circle, I want to say. It'll be easier to break, not as much surface area. So again, when solids, liquids, and gases change their state, right? Their state, their matter of state, or state of matter, however you want to say that. Again, the H2O is going to stay H2O ice, H2O liquid that we drink, and H2O vapor. So again, those molecules are staying as H2O as they're going through those changes. So it's the IMF between them that we're kind of separating apart. So again, here's hydrogen molecules. They're being held by what's called a dipole attraction. So here again, we have that the molecule is staying the same, but we have the force of attraction that's going to actually change and have them pull apart. So again, the lines, right, are the bonds within the water molecule, but our dashed lines here is the force of attraction between this hydrogen of one water molecule and the oxygen, those pairs of electrons of a different water molecule. So again, this is not in your notes. This is just a preview of understanding these 4 intermolecular forces. So this is what's called dispersion or London dispersion, and this means that there are 2 molecules that are very, very nonpolar. However, at some point, one might become polar, which means now it has a charge associated with it. And if the other guy next to it also becomes nonpolar for an instant, for a moment, then there might be some kind of attraction, an intermolecular force that causes the one nonpolar that's become polar and the other nonpolar that's now become polar. Now there's an attraction between that positive end and the negative end of another. So all substances will have what's called dispersion or London dispersion forces, and that's why it is the weakest of all the IMFs. So again, pause the video and please read over this information. And pause the video and read over this information. So what's dipole-dipole? Well, this is going to be the force of attraction between the negative oxygen from this guy and the positive sulfur from this guy. They are already polar molecules. They already possess that charge, those partial charges. So it is the attraction between the two. So if you have a dipole force, that means you can also have London dispersion forces. So again, pause the video and read. Pause the video and read. So hydrogen, however, is a little slightly different, and the difference is it's hydrogen from one molecule to NOF in a different molecule. So it's the fluorine from one, hydrogen of the other. That's the hydrogen bond. Again, oxygen from one, hydrogen of another. That's going to be the hydrogen bond. And again, we're going to talk about each of these a little bit more detail as we go through the section of notes. So if you have hydrogen bonding in a molecule, that means you will also have dipole-dipole forces and London dispersion forces. So again, pause the video and read. So hydrogen bonding is in DNA. So for those of you who remember biology or want to be a biochemist or things of that nature, again, a lot of hydrogen bonding is in that DNA molecule, right? So you have nitrogen and hydrogen from the adenine and the thymine. This is just an example. So you have lots of hydrogen bonding going on, and that's why that DNA is held together. And hydrogen bonding, let me say, is one of the stronger of those three forces that we just mentioned. And we're going to talk about the strengths. I actually teach you these strengths from weakest to strongest, just so again, it's kind of always in your head, that same format or that same order. I always talk about the weakest IMF to the strongest bond. So again, pause and make sure you're understanding this. Now, ion dipole, again, is going to be even a little stronger, and this is when we talked about dissolving, right? When we talk about dissolving salt into water, what happens? Well, those water molecules surround each of those ions. Well, that force of attraction between the water molecule, which would be the dipole, and the ion inside that it surrounds, that's where they come up with the ion dipole intermolecular force. So it's going to be the force of attraction between that ion that's floating around and those water molecules that are surrounding it. So what about an ionic bond, however? Well, again, pause the video and read over this information. And again, just some more information about the different types of interactions between those different species. And again, the strength. I'm always going from weakest to strongest. Now, they don't have some of the other intermolecular forces on here, but they do have what's called van der Waals, and we'll talk about that as well. Okay, see you in class.